So the first part of the lesson was a discussion on the first principle, that places have location, and we've talked about relative location, but we really need to talk about absolute location. Now this should be familiar to you as well in the fact that in Socials 8 and Socials 9 you were introduced to latitude and longitude, and you were also introduced to the grid system. So this should really be a review. So let's take a look at the grid system first. Now mine is very simple. Obviously in a page or on a map, the numbers will go higher than 4 and the letters will go higher than letters A to D. But you'll get the point. So let's say I'm looking for Kamloops. So I go to the back of the atlas and I find the gazetteer, I find Kamloops. And there will be bits of information in there. The first thing will be the page number. So it'll say page 10, let's say. The second bit of information will be a coordinate. It'll have a letter and then a number. So let's say it says C10, or pardon me, C3. It's on page 10. So C3, so I find C, and then I find the intersecting 3, and so this grid space here is going to be where I will find Kamloops. Now there's a huge advantage to that because of course it's much easier to look in this space that I've highlighted yellow than it is to look at the entire, so it's easier to look at this than it is to look at the entire page. So that's how the grid system works. And it's very, obviously useful. Now, what about something that's even more accurate than that? Well, we have absolute location. Now, on the right here, I've identified the major lines of latitude, and I've only put the numbers though. We actually need to label those. So let's do that. Here's my diagram. Now I'll make it a little bit bigger, but what you need to do is, and I'll walk you through this, is to label all of the major lines of latitude. So let's start at the equator, the easiest part. So there's your equator, 0 degrees north or south. If I work our way north, we have 23.5 degrees north, which is the Tropic of Cancer. Now I need to draw this line in, but it is the Arctic Circle. The Arctic Circle is right there. And it's 66.5 degrees north. And then the last one, which is at the very, very top, is 90 degrees north, which is the North Pole. Now if I work my way south, we have 23.5 degrees south, which is Tropic of Capricorn. 66.5 degrees south is the Antarctic Circle. And then at the very, very bottom is 90 degrees south, and that is the South Pole. And those are my major lines of latitude. Now, what about longitude? Well, one is labeled here for us, and it is the prime meridian. And it is 0 degrees, 0 degrees, and it is also called the Greenwich meridian. And the reason for that is because this line was actually determined at a conference in Greenwich, England, and the line was subsequently named after it. And Greenwich, England is approximately right about there. So the line actually goes right through the town. The town's actually quite small. Now, there's one other line of longitude that we need to talk about. Now, our map is two-dimensional, so we can't, flip the world over, which is ideally what we would be able to do. But on the other side of the world, I'll just put it over here, at 180 degrees is the international date line. International date line. And that actually tells us when the next day is going to start. I actually have a cool diagram here. I'm going to tell you how you can have your birthday 2 days in a row. Okay. So your diagram should look something like this. Now the other thing before we talk about the international date line that I want to show you is the high, mid, and low latitudes. Now this isn't in your notes, I just want to throw it in there. If you are wanting to talk about high latitudes, what you're looking at is from 60 degrees north or south to the poles, which is 90 degrees north or south. Those are considered high latitudes. Mid latitudes are 30 degrees north or south to 60 degrees north or south. Those are considered mid latitudes. And then, of course, the low latitudes are right near the equator. You've got 0 degrees to 30 degrees north or south. And we'll just scroll back up again and take a look at what that looks like actually on a picture of an Earth. Okay, so how do you have your birthday 2 days in a row? Well, taking a look at this diagram here, here's the international date line, which I'll highlight, this red line here. Now, as I mentioned before, it doesn't follow the 180 degrees exactly, and the reason for that is because they had an international conference, and there were some of the islands in the Pacific that wanted to be on one side rather than the other, and it was just internationally agreed upon. This is one of the examples of that down near Australia. For the most part, it does follow the 180, but once you get into the northern hemisphere, up into the Arctic region, it starts to have that jagged line again, where it falls off the 180 degree mark. Okay, so in the eastern hemisphere, so let's set this up. In the eastern hemisphere, you are 1 day ahead. So let's say it's Saturday, January 4th, and that's your birthday. So on that day, party hard. Just make sure that you're either in Australia, Fiji, Tonga, or New Zealand. Any of those islands, be on any of those islands on January 4th. Now, in the meantime, while it's Saturday, January 4th on this side, on the other side of the international date line, it is Friday, January 3rd. You're actually behind a day, and that's in the Western Hemisphere. And that's where we are, by the way. Vancouver, BC is in the Western Hemisphere, so we're always a day behind. So party on Saturday, January 4th on this side, wait a day. Then what you need to do from one of these 4 locations, move to Samoa or Tahiti, and then you can have your birthday again the next day, because if you take a look, this becomes Sunday, January 5th. Over here, we go back. It is now Saturday, January 4th. So you can actually have your birthday 2 days in a row. So let's say this is on one of the islands of Haiti, the western side of Haiti. Now, let's use the grid system here. So if I were given a grid, the numbers would be 1 and 2, because I only have 2 grids on this side. If I put the letters on the bottom, what would it say in the gazetteer if I was looking for Port-au-Prince? Well, it would say C1. So that's how the grid system would work. What about if we were using lines of latitude and longitude? Well, here's my lines of latitude, which of course I've already told you goes first. North and south directions always go first. So if I was looking for Port-au-Prince, in the gazetteer it would say something like 18.5 degrees north and 72.3 degrees west. And that's how that would work for that. Now, what about another diagram? Let's take a look. This is how the lines of latitude are determined. And you can see that if we have the equator, which is right here, how they determine the lines of latitude is the degree with which they are from that line. So this here is 80 degrees. So all of this line is 80 degrees. And it would be north. Longitude, where's 0 degrees? So this is my prime meridian. If we are 80 degrees this way to the east, then this line, all of it from north to south, is 80 degrees west. Or pardon me, east. Now I think I made a mistake here. Oops. Let me see here. This actually, it indicates 55 degrees north. So actually I drew that wrong. This should be from the equator, you go 55 degrees north. This here should be 55 degrees north. Okay, so that's how that works. Now here's some other diagrams that'll show that maybe a little bit better. If we were able to cut the Earth in half vertically, this is what the lines of latitude would look like. If we were to do the same thing but longitude, this is what it would look like. And that's how they come up with those lines. It really is, it turns into geometry. Now, the other thing that I need to tell you about is GPS technology, which of course uses satellite images. And we are very familiar with this. They are in our GPS is in our cell phones. But I think you might be surprised that you can also find them in shoes. You can also find them in backpacks. And the reason for that is that parents, of course, in this day and age, we do have to worry about child predators. And this is one way of locating their child really easily. That's why a lot of parents actually they want to get a phone for you guys that has GPS technology, because they could just find you in an instant. Well, actually, technically, they find your phone. They may not necessarily find you. So GPS technology, just to give you a little bit of a history, originally it was actually used by the U.S. military during the Gulf War, the Persian Gulf War in the early 1990s. And the purpose of it was they wanted to minimize civilian casualties. So they developed this technology using satellites where they could pinpoint with quite accuracy, actually, they've even refined it now since then, so that they could drop their smart bombs on certain locations so that the least amount of civilians would be killed. And of course now we use it for all sorts of things. Now, how does that GPS work? Well, this diagram explains it quite nicely. You have your satellite. It sends a signal to either your phone or your car. Like I know our car has GPS, and so does our truck. And it sends a signal from the satellite, or it receives a signal from the satellite. The car or truck then sends the signal to a tower, and then that signal, via a voice call or whatever, is then sent to your carrier. Now your carrier could be OnStar, which we have in our truck, or it could be a cell phone or provider such as Bell, Rogers, TELUS, and then that's how they find your location. So the first guiding principle, places have a location, is actually quite comprehensive. You can talk about relative location. You can also talk about absolute location. Either way, every place on Earth, you were able to find it by using those two methods.